Hello, my name is Karen Hui, and I'll be helping facilitate today's webinar, Observability as Code with Terraform and Splunk. During this session, we will explore and discuss how to provision monitoring assets using Terraform Providers alongside infrastructure and applications to achieve consistent observability and effective collaboration. Please feel free to type your questions during the webinar using the Q&A feature. This webinar will be recorded, and the recording will be available after post-processing, which usually takes 2 days. Now, I have the pleasure to introduce our speakers, Corey Watson, Technical Director and Evangelist with Splunk, and Michelle Greer, Senior Product Marketing Manager, Terraform Cloud with HashiCorp. We will finish with a Q&A session, and I'm going to hand over to Michelle, who will start the presentation. Thank you, Michelle.
Hello, everybody. Good morning, good afternoon. So we're going to be going over observability as code. So our agenda for the day, if you're not familiar with Terraform and infrastructure as code, we're going to be going over that as well as Terraform Cloud. We'll go briefly over 0.13 and what you can expect in that. And then I'm going to hand things over to Corey, and he's going to be talking about observability. So he's going to talk about how it matters, kind of into the concepts of observability as code and what to look out for, as well as the integrations between Terraform and Splunk. So without further ado, this is me. My name is Michelle Greer. I'm a product marketing manager at HashiCorp. I focus on Terraform Cloud, and I am located just outside the lovely city of Austin, Texas. So it's nice to see you guys. First, we're going to get into infrastructure as code and why you would provision infrastructure as code. So as you may know, modern DevOps can get pretty unruly. I mean, if you're like a lot of modern teams, you've got, parts of your infrastructure on AWS, you've got parts on Azure possibly. You may have provisioned databases as a service, various observability tools, monitoring tools. It's a lot of consoles to log into. It's a lot to manage. It's very dynamic in its nature. So fortunately, these cloud services can be leveraged via APIs, right? There's an API for that. And so these APIs allow us to provision infrastructure as code, as well as manage it. So infrastructure as code through Terraform introduces a single workflow to manage all of this infrastructure. And so when you have, when you're provisioning infrastructure as code, you can improve automation, and you can also reduce human error, and everybody wants to do that. So infrastructure as code also allows you to create what we call in Terraform as our modules. And so a module is a container of resources that are used together. So a good example of this would be potentially your front end, database, observability could be a module, like anything that you want to actually contain together and use together and give people access to, you could provision as a module. And so how do you get started with modules? Well, with Terraform, there's a whole library of them. So you don't have to build it yourself. You can go to registry.terraform.io and find modules for over 200 different cloud infrastructure tools, including AWS, Azure, VMware, etc. So we've talked about a little bit about the kind of abstracts of infrastructure as code and why you would want to get into it. So let's actually look at it. We don't want to get too much in the weeds in terms of what infrastructure as code looks like. But with Terraform, you provision infrastructure as code with what's called the HashiCorp configuration language. And so this was created from its foundation to be very consistent and easy to read and easy to write. So here at HashiCorp, we have a lot of customers who, they're not really big on scripting. They're not what they would consider them. They wouldn't consider themselves developers, but they're able to provision all of their infrastructure as code using HCL. And so this approach allows our customers to break up their infrastructure into modules. And so most of you are probably familiar with this, but very easy to create, change, and destroy using this single Terraform workflow. So I don't know if you guys have signed up, but if you're using Terraform in production, especially if you're collaborating with others, you should be using Terraform Cloud. So Terraform Cloud provides the optimal workflow for collaborating with Terraform. And so you can use it via GUI, you can use it via an API, or you can use it via CLI. And the advantage of using Terraform Cloud is pretty straightforward. there's a few of them, but the big one is, say Corey and I are working on infrastructure, and we both have our state file, which the state file is it essentially maps my configuration to what is actually provisioned in the real world. If he has his state file on his local machine and I have mine on my local machine, and then he goes to make a change, that change would not be reflected in my state file. So Terraform Cloud provides remote state for free. We do encourage all of our Terraform users to try it out. You can also automate runs straight from version control. So very convenient feature. And then also, you're probably trying to implement principle of least privilege with your team. That's the responsible way to go. And so Terraform Cloud has role-based access controls, and you can actually provision policy as code using something called Sentinel. And so Corey will go into that a little bit later as it pertains to observability. So this is my shameless plug for Terraform 0.13. This is currently in beta, and it's going to be going into GA very soon. And so I do encourage you to check it out. It does, if you're using modules, it improves, it has a lot of usability improvements, which you'll appreciate. It makes it easier to collaborate with because it is the first major addition that actually integrates with Terraform Cloud using Terraform login. And then, as you'll notice, kind of moving forward, it's going to be a lot easier to set up community providers with Terraform. It's going to be just as easy as it would be to set up an official provider, and everything's going to be will be eventually moved into the registry. So you'll be able to find these community providers with a lot less work. So if you'd like to learn more, if you haven't already signed up for Terraform Cloud, you can do so at terraform.io. You can also just download the binary there as well if you want to get started. If you haven't actually used HCL yet, we actually have tutorials available at learn.hashicorp.com/Terraform, very step-by-step instructions. And if you want to check out all of the different providers that you can use with Terraform, just go to registry.terraform.io and you'll be able to find the official providers, and it will also link you to some of the community providers that are available as well. So with that, I'm going to pass things over to Corey, where he's going to talk a little bit more about observability.
All right, I was muted, which is awesome because I was talking, because I'm a professional presenter. Okay, so thank you, Michelle, and thank you, Karen, for the intros. I'm going to be talking about observability as code with Terraform, specifically around Splunk and SignalFX, which I will now get focused on the right window and then tell you first about our agenda before I tell you about me. So we're going to talk today not about specifically the syntax of the provider and stuff. We'll come to that a little bit later. We're going to talk about this more strategically, like how does one deploy observability as code inside your infrastructure in a way that benefits everybody and that's scalable and that we can all sort of raise the water level for all boats, right? We'll also cover some general stuff like dashboard design, which is and reusability and standards, mainly to help you understand how you can get everyone to benefit instead of just thinking of this as, say, one-off dashboards for individuals inside your org. We'll talk about monitoring and feedback, some ideas that are very close to my heart, like not just doing alerting and detection and stuff, but also how we can actually, I got a cool kitchen timer to watch me. There we go. Now I got it going. Now I can keep track of time. So we want to be able to give feedback about these alerts. Like if people are getting alerted in the middle of the night, we want to make sure that we can get feedback on whether or not it's working. And then lastly, some discussion that's even beyond a little bit of Terraform, but how with observability, you can improve your stance by knowing your tools a little bit better. So with all that said, why should you listen to anything I say? Well, I'm Corey Watson, and as previously mentioned, I work at Splunk by way of SignalFX. So SignalFX was acquired by Splunk last year, which is how I got here. So I do a little bit of advocacy, I do a little bit of practice, a little bit of engineering. I happen to work on our Terraform provider, so if you have issues with the SignalFX Terraform provider, you can talk to me. And I also work on a little bit of product stuff. So I previously, at past gigs, I used to work at Stripe, where I was principal engineer and created and led the observability team. And then before that, I was an SRE at Twitter, and then later the engineering manager for the observability team. So I say all that to articulate sort of why observability is a big deal for me and why I have some past experiences that could be helpful to you. over the past year and a half in my time at Splunk and SignalFX, I've spent a lot of this time talking with customers about these types of issues, learning from them, helping them with ideas about how they can deploy it a little bit better, as well as my past experiences as a practitioner. So I like to joke that I've got about 10 plus years of collected on-call rage from all of the people who have been my customers. And, 20 years of on-call on top of that. So the point, though, is about all this is that I've actually used a bunch of this stuff in production. I still use it on a regular basis. And being the Terraform provider for us, or the maintainer of that provider, I certainly know a lot about how to get it out there into the world. So anyway, if you're not familiar with Splunk, Splunk is the big data to everything platform. I already mentioned, of course, SignalFX briefly. If you're not familiar with SignalFX, this is the part where product management insists that I talk about the product and pitch a little bit. Splunk covers, of course, a number of products. SignalFX is a real-time monitoring and metrics platform. Also APM, some other stuff. I'm sure I'm leaving something out, and product marketing is irritated at me already. But the point is that these are tools that you use to monitor and keep an eye on your system. So we may use them actively during deploys, or when production is actively doing stuff, or we may be using them after hours whenever there's no one to stare at the chart. What better way to stare at charts than have robots do it for us? And so SignalFX, being a real-time platform for metrics and APM, can sort of hook directly into your deployment processes, all these other things, to tell you if things are working correctly. And then you can sort of analyze and bring all that data together with Splunk, both, I was going to say after the fact, but not just after the fact. It can go pretty fast too. Anyway, so this is a screenshot of SignalFX sort of doing its thing. If you're interested in checking out SignalFX, you can go to signalfx.com/free trial. This is meant to demonstrate a little bit of infrastructure stuff, a little bit of metric stuff. I didn't want to fill this up with screenshots and product plugs, but there's also cool APM stuff that's in here, integrations with tons of cloud providers, things like HashiCorp with stuff like Vault. So we're sort of all over the place. I'd love you to check it out. Pays my salary, so please do that. But let's move back on to sort of the meat of the situation, which is to talk about Terraform. So I mentioned earlier that I'm not going to go through and show you a whole lot of syntax today. Michelle already mentioned that we're not going to get deep into HCL. So I'm not going to show you a whole bunch of HCL today and make you read a bunch of code. That's not terribly easy to follow, and the syntax is weird and stuff, and it's never big enough on the screen. So instead, I'm just going to point out that just like all official providers, our provider is on HashiCorp's website under the provider documentation. And it's very thorough. Every single resource that we support is there, all the arguments, all the outputs, data sources, all that sort of stuff. It's built in there. If you ever see any problems with it, please file tickets for me. I'm quite happy to fix them. But we're not going to bear down on this, because you can go read the documentation yourself. It's a great reference, and if you need that, you can get there. Instead, we're going to talk about these more high-level concepts today. But I said I wouldn't, but I'm still going to show it to you because I kind of have to. We need something to use as a sort of touch point here. So this is an example of a SignalFX detector. If you've done anything with Terraform, this looks very familiar to you. If you haven't, then we are saying at the top that this is a resource of type SignalFX detector, and it's called application delay. That's the name, the unique name that we're giving it. And then a whole bunch of stuff here that tells SignalFX and Terraform what to do. So we're going to give it a name and a description, some other things that like max delay and authorized writer teams that don't mean anything to you, some program text, and then some rules. So this is us building something that's going to keep an eye on whether or not our application is slow, and we'll be able to see this 24/7, 365 and get very quick and accurate notification if anything goes wrong. So this is the type of thing that you would normally manage with your Terraform provider. But the interesting thing to me about observability and the systems that you're putting out into the world is that it's sort of mutually beneficial. Observability is generally a quality that you want your systems to have. Most every talk about observability has a slide that defines observability. I resisted the temptation to do that here, but it's a quality of a system, right? How good of a job does this system do giving us information about what it's doing right now? Is it currently fast? Is it currently slow? Why are those things happening? All that type of stuff. And so if that's a desirable trait, then things that are observable, people are maybe more likely to use. So if you happen to be internally to your company, like you work on a library or a service or middleware or a platform, making that thing more observable is more likely to attract a few people to your product or whatever that is. I think of it all as products, even internally. But there's also sort of the flip side to that, that if you've got a system that you want. So if you want people to use it, you make it observable. But sometimes we need people to do observability because it is often a means to an end. So sometimes the relationship is the opposite. Sometimes we're taking a platform that we all are already using, or a piece of middleware that we're already using, and we need to add observability to it. And so sometimes we're sort of attracting people to the product with observability, and sometimes we're attracting people to observability with the product. It's very mutually beneficial, and I think that's neat because we're just trying to make a better tool, a better platform, what have you. So I want to talk specifically. I love this slide. We have this in our slide deck, and I always use it for the funny, ironic slides for some reason, but because the guy's so happy looking. But you can definitely go out and you can personally, just like Michelle was saying earlier, if we were working on a project, you can keep your local state file. You can build dashboards. You can build detectors, all that stuff. You can do that by hand if you want to, just on your local machine. But that's not really where this stuff is the most powerful. The place that this is the most powerful is not one-off dashboards or one-off individuals doing stuff. It's the entire organization deploying these assets, these whatever they are, the dashboards, the charts, the alerts, all that sort of stuff. Any of those things are all very powerful for the entire organization. We don't want everybody sort of doing this in isolation. We want to be strategic about it. We want to make sure that the entire org benefits, that everybody sort of gets best practices and all that kind of stuff. And so we're going to talk today about how to use these tools to get this done. So you're going to have a whole lot of decisions to make whenever you're trying to apply all the ideas in observability and monitoring or whatever. I don't have all the answers for this stuff. And the reason is that it's easy to sort of go and pick a tool, an observability tool, even something like Terraform or what have you. But what's difficult is to sort of apply this stuff socially. Most of these really become sort of socio-technical problems. So this is an important point I want to make clear, that, you know, no matter how big or cool of a tool you buy, there's still a whole lot of social work that you're going to have to do. We have to explain SLOs and error budgets to people, but we also need these people to sort of get this stuff as easily as possible. Anybody can sort of read the SRE book and understand what an error budget is, but that doesn't mean that people know how to calculate it effectively, or that everyone's using sort of the same definition inside our org about what an error budget is or how it should be applied to the systems that we operate. So we need to follow through as practitioners, as leaders, as full organizations to try and improve everybody's experience here. And that's why we're talking about this strategically today, because every individual person or team making these decisions alone can be very frustrating. And we're trying to sort of, leverage these tools to make everyone more effective and give everybody bigger strength. Now, I'm going to spend a little bit of time talking about some high-level principles here about how one should go out and design this stuff. And this is supposed to be partially illustrative about why it's important that you don't let everybody hand build dashboards. This is all sort of building up to a plug for Terraform modules. But we want to talk a little bit about dashboard design. I think it's interesting that pretty much everybody who works in an engineering role at some time or another is expected to build some sort of dashboard. It could be a diagnostic dashboard for infrastructure or debugging purposes. It could be a dashboard for KPIs about reliability, or it could be just something that you use to make sure things that the deploy that you just did is functioning correctly. Like, did that code go out into the world and is the customer using it? But you never see that in any job description. Like, we're never really asked, do we know how to make good dashboards? And this is something I've spent a lot of time on in my role, is like, how do we do good dashboard design? And then this is something that will play into how to leverage this for more of the organization using modules. So when you build a dashboard, and this may seem a little bit intuitive, but I don't think we often pay as much attention to it when we're building dashboards. They're very, what's the word I want? Organic. You know, you sort of like throw a chart here, throw a chart there. Every time there's a problem, you add a chart onto the end of it. It's sort of incident-driven development is the way that I like to think of it, or incident-driven design. But if we want to build a good dashboard, we have to think about what it is that the person who is looking at this dashboard is trying to figure out. Is this a dashboard meant to understand the performance of the system? Is it for the support staff to know if customers have been impacted? Is it for the customer to understand how many dollars they've, processed in a given day? All these are good goals for people to have, but our dashboards need to support them. And so if you want to build a good dashboard, I'm going to give you some high-level ideas. The first one here is that dashboards are basically grids that are prioritized. And humans are really, really good at sort of looking at grids and understanding squares and locations. And even our memories are good at remembering that the top left corner is this chart and the bottom right corner is that chart. And our eyes can flick to and from these things very fast, pre-processing. Like, we don't even have to think about it. Our brains are very good at it. And so as a result, you need to think about what's the most important thing that you're going to show on this chart, or sorry, on this dashboard. That one should be in the top left, and the bottom right should probably be less important. Now, if any of you are not working in languages where people read right to left, or they instead read left to right, then you may need to change this. Some languages work that way, others don't, some top to bottom. So make sure you know your audience well and be inclusive of that, because sometimes people read in different directions. And so this left to right thing or right to left thing is predominantly something based on how we usually read. Also, there's if you're not familiar with RED and use, I'll briefly mention those. RED stands for requests, errors, and durations. Use stands for utilization, saturation, and errors. These are patterns that have been popularized over the last few years to sort of give people a baseline understanding of how a service is operating. Pretty much any service can be thought of in RED terms. Like, you may be thinking of like an RPC process, like an HTTP service, right? It receives a number of HTTP requests. Some of them are errors, and all of them take a certain amount of time. But you can also map this to systems like, I don't know, grocery checkout. Like, how many people come to check out at the grocery line? How many times is there some sort of an error? And then how much time does each one of the checkouts take? Use is a little different, because utilization is how often is the service busy? Like, in a given minute, is it busy only 30 seconds out of that minute, or is it busy the entire time? Saturation is how many things are waiting for it. So maybe we've got a queue and there's a bunch of things stacked up. The reason that I'm mentioning these is that typically these are the types of things that you're expecting to be at the top of the dashboard, hence this illustration. So RED and use tend to be high up because they're very common ways for everybody to think about the operation of a service. Now, this would not be appropriate if someone was building, say, a dashboard for leadership that shows the number of new signups in a given day. That's why it's so important for you to understand your goals and to remember that design is never really neutral. When you come in and you build something, even if you're not thinking about design, you're still building it based on the biases that you have. So after that, I'll mention that these RED and use are not, sort of causes of problems. They're just symptoms. They sort of describe what the problem is doing, sort of like, checking your temperature or how tall you are on a given day, right? When you go to the doctor. So then below RED and use, again, in a diagnostic dashboard, you're typically going to put stuff that's symptom-based. So like, what are symptoms that users experience? Maybe there's, the age of a given item in a queue or something like that, because the idea is to process things promptly. And you want to group them together with like materials. You want to see, say, all the things related to, say, image processing are grouped up together, because you want to be able to compare them. The human eye is very good at seeing two things together and sort of doing a comparison, making sure that like the magnitudes and the XY axes, or the Y axes probably, X is almost always time, but the Y axes are similar, all that sort of stuff. And so these are sort of what you do below the RED and use metrics, which typically show up at the top of your dashboard. So that's a lot of stuff about layouts. Let's move on to something else. So these are a little less sort of prescriptive in terms of shape, but these are things that I think are extremely important when designing good dashboards. And the first one is to avoid dead ends. Whenever you are investigating a problem, I'm sure many of you have spent many an afternoon or evening or even morning sort of poking around trying to figure out why something was going on. You very rarely find your full answer in one dashboard. You sort of have to click around. Maybe the first dashboard gives you a strong indication as to what the symptom is, and then through either your mental model of how the system works or some other guidance, you're able to sort of jump to another place. Maybe dig around in some logs, or look at a trace, or maybe find another dashboard of operating system metrics. The important thing about this is that you should support your humans being able to jump to these other data sources without having to know it already. That mental model thing that I mentioned earlier is really important. We need to know how these systems are sort of built together. Like when the first week or two of any job, you always end up at a whiteboard and somebody sketches out how it works. If you can build these sort of connections into your dashboards, it's really powerful. So maybe you've got a dashboard that's showing there's some number of errors, and then in the top right, maybe you've got a little thing you can click that lets you link that over to, well, go check this out in Splunk. I want to go look at the logs. Or maybe let's go look at the aggregate traces or something to that effect. So avoiding dead ends, giving people a way to sort of hop around, but at the same time, not linking them to a bunch of like one-off dashboards. We want to try to keep as many sort of central, well-maintained dashboards, because we want to make sure that they're of good design and that they answer the questions that people have. Lastly, remember that even though we're talking mostly about dashboards here today, that you also need to support analytic interfaces. Sometimes people just want to see, the high-level lines and the trends in their charts, But at other times, they actually want to go in and they want to slice and dice and they want to manipulate the queries and stuff. That's called an analytical interface instead of a perceptual interface. So we want to make sure we support that, linking people to other tools. Maybe we link them over to our feature flag tool because we need them to be able to enable or disable something. Maybe we link them over to a BI tool to say like, well, what's the history of this customer's interactions been over the last 6 months? Or maybe our support tools internally so we can look up their tickets. Anything to sort of allow people to get into that mode of asking more and getting answers back to their questions, because in many cases, just looking at the chart only describes sort of what's happening, not necessarily why. So we've talked a little bit about design there. We know now that, you know, we've got to design dashboards in a certain way. We've got to be conscious of our user and know what we're building, and then use our knowledge of building good dashboards or good alerts. We'll talk about that more later. And we want to take that knowledge and we want to give it to everybody. Now, one way you could do that is to, I don't know, hold education sessions, right? Make everybody come to a webinar at noon Central Time on a Thursday and learn how to build that thing. But that's not really going to work inside the organization. We don't necessarily need it to. We don't want everybody in the org to have sort of, you know, to be flat in knowledge. And that's not how organizations work anyway. Knowledge is not evenly distributed. So we want to do our best to give people the opportunity to benefit from all this work without necessarily having to invest in learning all of it. It's always good to learn it. We don't want to stop them. But at the same time, let's just make it so that everybody starts off in a good place. And for that, we want things to be reusable and we want to keep standards inside the organization. So the best thing that you can do for this is to leverage modularity. If you've got an SRE function inside your organization, this is a place that this sort of stuff often lies. People in the SRE org maybe understand how to build out SLOs and SLIs, and they know how to help you pick which KPIs go into your SLOs. They also may have some opinions about error budgets and some other things. And so in those cases, that org would probably build some of the tools that we're about to talk about. Or maybe you've got a full-on observability team. That's certainly something that I've had in my past at many organizations. And in many cases, those are the ones that help you with things like, how does one successfully, or I was going to say successful twice, how does one accurately calculate a success rate or a failure rate? The math for that's not always obvious. And even if it is obvious at a high level, your metrics may not always be in the shape that you need to do those calculations. And so having an observability team or an SRE team or whatever maps to that in your organization can help to build out some modular capabilities that anybody in the org can sort of snap together to build something, you know, better for them right out of the box. So we already saw, well, we saw some HCL earlier that Michelle showed, and I thought when we did a dry run of this yesterday, it showed a module, and I was like, oh no, I did too, but she didn't. So I get to show you a module in use. So in this case, this is again HCL, HashiCorp Configuration Language, which is the thing that Terraform uses most of the time. And what we're telling it is, instead of defining a resource, which is what you saw earlier, we're now going to load a module. And so a module is just like, you know, in most of your programming languages, you can import some library from somewhere, like a jar or a Python library or a gem or something to that effect. And so in this case, we're going to load a module and give it a name. This name, by the way, at the top, the service baseline, my service, that's arbitrary. You can make it anything you want as long as it's unique. But the next thing we're going to do is define a source. We're going to say, hey, I want you to go to github.com/mycompany/some module name. This is one that works on GitHub. As Michelle told you earlier, you could also use the private registries that come with Terraform Cloud to store these modules. And what's really powerful about them is sort of demonstrated in the next line. This is probably familiar to you if you've done any sort of dependency management in any programming language, but you can see here that we've specified that the version can be greater than or equal to 1.20. So what's really cool about this is that Hashi bothered to include something that allows us to opt into and control the version over time. So if today I built a cool dashboard and Michelle was using it in her services, then she can protect herself from maybe an unwanted upgrade, or she can say, hey, I just want to get, you know, point upgrades for a while. And that gives me, as the author of the module, some freedom to break compatibility in the future or sort of allow people to opt into larger change. But anyway, the next section that's in sort of the dark teal box is the parameterized, the parameters that go into these modules, because these modules can be set up to be parameterized. So in this case, I'm giving it a couple things. These are not, by the way, hard-coded. These can be anything you want. I've chosen in this illustration to say, hey, tell me the name of your service and tell me the name of your team. And with the name of the service and the name of the team, I can then use the standards inside the organization to go and fetch metrics that I know exist. Let's say that I've got, I don't know, a service mesh, or maybe I use HA proxy or hot proxy, however people say it, as my sort of termination before I get into my services on the box. That would give me red metrics for free. I know that, well, every box uses the service mesh, so I can use the service mesh to get my red metrics and preemptively calculate all of that and just put it all on the screen for everybody. I can use that to calculate your SLOs about availability or maybe the latency of your service. And then I can also create detectors and all that other stuff for you automatically. And then you can choose when and how you upgrade in the future. And so that's cool. This is, you know, sort of mechanical. You can see the config language, but this is a module that I've got a link to it at the bottom. This, of course, only works with SignalFX. I'm sure you could make something for other providers as well. But this is, I forgot this was an example called Poop API. This dashboard is meant to be illustrative of what you can do with something like a Terraform module that builds out your dashboards for you. And a bunch of the stuff that I've done here, I gave a talk at Monitorama last year about how to build good dashboards, which you saw just a brief bit of before. But there's a bunch of stuff in this example that I'm showing you that you can do because the module takes care of everything for you. Because we're using standards, we know how to get the request rate, the operation duration, the rate of errors. We can get all of that and pull it out of your service without you having to do anything except tell us the name, because we've used standards inside our org. And these standards, by the way, would be naming conventions of your metrics or of your traces or of your log lines or whatever it is. Here, we've also taken the time to build detectors that go along with it. So we can use your SLO to then go ahead and build a detector that says, well, this SLO for this API is 99% uptime. So therefore, I'll go ahead and preemptively put that into a detector. And then I've built those detectors for you in the module and connected them back to the charts. So now all the charts have detectors behind them, and we can see because they've got nice little green lines. By the way, SignalFX does have a colorblind mode, so you can switch over to that. So it's not necessarily green or red. It's something that works better with color blindness. But we can see that these charts are all safe, which that's even better, right? We don't have to look at this and then reason about it like, well, I don't know, is 397 milliseconds fast or slow for this API? We know it's okay because the entire chart's green and it's connected to a detector that'll tell us if it fails. Our top right chart, well, actually all the top three, show annotations as well. Each one of those are deploy events or feature flag changes. So we can see contextually that we can correlate, well, that deploy didn't line up with the latency that I saw. So I know that's probably not necessarily the thing contributing to my problem right now. We've also got units in here. Something that people very commonly leave out of their metrics and their dashboards is what the units are. They'll say like, okay, well, I see that the current operation duration is 397, but is it 397 seconds, milliseconds, nanoseconds? I don't know. And so by putting that on the screen, we're able to more easily get that information into people's brains because they can process it. And then lastly, we've got connections to additional information and tools. It'd be hard to show that in the screenshot. Labels and bounds, because we know that where the SLO is, what the target is, all that sort of stuff. Again, you can check out that Terraform module. I didn't make it for use in production. It may be great, but it's just supposed to be illustrative of what you can do with Terraform modules. So that's an example of the types of things that Michelle and I have been talking about here today. I'd love for you to check it out and shoot me any feedback that you've got. So the other thing that you can do with this that's really important is we need people to be able to customize these a little bit. We can't just make all their dashboards and then not allow them to manipulate them a little, because different services, different operators are going to have different needs and different preferences on how they use their tools. So we need to make sure we have the capability to filter things. One of the features of many dashboarding tools, you can put filters at the top, maybe filter by, region, availability zone, something like that. And also to be able to slice and dice, like say, hey, I want to chop this up and see this chart broken out by that region, because I want to compare if we're having a different problem in, say, US West 1 versus, US East 2, something like that. We also want to make sure that there's an opportunity for different events and annotations. You don't necessarily want to see every deploy of every service across the entire org, so we want to scope it to one service. But you may want to occasionally turn on some other annotations, like, show me DNS failover, show me Puppet runs that we've done on the boxes. Those are not things you want to maybe noise up your dashboards with by default, but you can add them later. Additional charts or views are something that people will commonly want. Their services may follow red and use to get the basics, but if you want to follow some extra stuff, like I mentioned earlier, the age of an item in the queue, maybe that's something that's unique to one service. They're probably going to want to tack one on to the end. And you can do that with Terraform modules. The Terraform module can be set up in such a way that it like outputs a list of charts, and then the user could like append one on to the end before that chart gets created by the Terraform provider. A little more advanced, but you can see an example of that in the module that I linked earlier. And lastly, we want to make sure we have links to those outside bits, whatever they are. Like I said earlier, maybe internal support tools, feature flags, logging engines, whatever they are, to be able to get people out to those other tools where they may be able to find more information or actually get into solving the problem by, say, rolling back a deploy or changing a feature flag. So lastly, in this space at least, I want to talk a little bit about treating it like a product. At the end of the day, this has been a big deal for me. I mentioned earlier that 10 years of engineer rage, because people love to, there's no better way to lose friends in an organization than becoming the person who owns alerting, by the way. The important thing about it is you got to treat it like a product. You need to keep a change log of all the things that you're building. And this could be for an entire observability team, or it could be just for the Terraform module that you work on. Change logs are really important. How else are you going to communicate to people all the cool stuff that you've done? In some respects, that's because maybe they come looking for a bug, but in other cases, maybe they just want to see the cool work that you're doing. You want to control that narrative, help them understand what it is that you're doing and how you're improving systems overall. And that's also important because we want to celebrate this stuff. Your sort of culture in your org are the things that, well, culture in an org is often the things that people expect to happen, not what actually does happen. But we want to make sure that we're celebrating the improvements, that we make this type of work, this type of investment in our reliability and resiliency. We want to make it something that we support internally with celebration, like it should be considered a good thing when people work on this stuff. We don't want this to be quiet glue work that people don't get rewarded and don't get credit for. And then lastly, we want to make sure that we are getting feedback about this process. And an important part of getting feedback from people is following up when you're done. So if I work on this and I change the dashboards in such a way that Michelle doesn't really like it, and Michelle says, hey, Corey, I didn't really like that change you made to like the colors of that one chart. And if I'm like, oh, okay, cool, thanks, and I just never follow up, that's not a very good experience for her. She's unlikely to give me feedback in the future. But if I later either make the change and follow up with her, she'll be like, oh, that's cool, thanks for following up. Or if I follow up and say, hey, I know you didn't love that, but I want you to check out the fact that we got a bunch of other feedback where people really liked it. And while I hope you'll continue to give us feedback in the future, we're going to leave it the way it is. Sometimes saying no is really hard. It's easier to not talk to people. But if you give people if people give you feedback and you give it back, then we start this nice feedback loop and everybody's happy. So next, I want to talk about monitoring and feedback. So how do we handle monitoring internally, and how do we get feedback on that stuff? I've mentioned feedback a few times. Let's talk about how to get it. I've already made this joke about it's a great way to lose friends to own the monitoring platform, but it's fine. Like at 3 o'clock in the morning when something wakes you up, it kind of makes you angry. And we have this sort of, I already mentioned sort of incident-driven development. What is the remediation of most incidents? It's sort of frustratingly just add an alert. And then before you know it, whenever something goes wrong, you get 40 different alerts. None of them know that they've already paid you, so all of them paid you simultaneously. There's a really good older paper, I think from the 80s, by Don Norman, who wrote the book, The Design of Everyday Things, that says, it basically goes on for like a paragraph explaining that modern systems are not quite good enough yet. This is still true. But we do know one thing about modern systems, and that's that adding more alerts doesn't solve any problems. And I think it's funny that that's, I think, a 40-year-old paper, and we're still busy making that mistake over and over today. But if you're going to make alerts, then the things we want to do when it comes to modularity and trying to help people is we want to get best practices out in the world. We want to help them, especially with math or some of the weird little things that can happen, like what if the metric is slow to arrive? What if the metric disappears? What if it's an error metric and it's 0 for like 6 days? All these are things that we can help them with. And lastly, we need to make sure they are putting context into the alert. What's worse than getting paged and not knowing that the alert is actually for QA? And well, I don't care if QA is broken. Why wasn't that in the subject? Why didn't I get that, when VictorOps or PagerDuty or what have you sent me that message? Why was that not there? Those are the types of things we can really help people with, including things like regions. Was it in, west or east or something like that? So when it comes to making a good alert, this is a plug for something I created called the case method. The idea behind good metrics, just like we have these mnemonics to remember how to use and read to make good metrics, case is meant to remind you that alerting should be context heavy, like I mentioned just now, should have lots of information about what's going on in the system. It should be actionable. Don't page people for something that, well, I don't know if I'm supposed to do anything. Like, I see that it's out of file handles, but am I supposed to do something when one box runs out of file handles? Is that bad? Symptom-based. I know that 5 years ago, there was that one incident when that thing ran out of file handles, but I think we fixed that problem now. Why is that still something that we have an alert for? So that is something that's based on a cause, not on a symptom. When you go to the doctor now, the doctor doesn't ask you to take a test for every available sickness in the world. They ask you for your sort of basic, there's a name for that. I did this the other day. I blanked saying what the name was. But they ask you for, like, have you lost weight recently? And are you feeling okay? And what's your temperature? All that sort of stuff. That's the stuff you should be paying attention to in your alerts. And lastly, you should be evaluating them regularly. Are they working? This is a weird analogy, but it's sort of like the signs on, or the pieces of paper on the back of bathroom doors that, like, when was the last time someone looked at this and made sure that the bathroom was still functioning? When was the last time someone looked at this alert? Is it doing the job it's supposed to? Should it even exist anymore? Has it ever even fired? That sort of thing. So Case is meant to help you make better alerts. And this is something that you can roll into your modules that you use to build alerts and stuff like that for your org. So how does one collect feedback then? We've talked about this. I've alluded to it a couple times. Well, first off, we need to know, was this alert helpful in the moment? Like, sort of thumbs up, thumbs down. What could be improved about it? All this is stuff that you can do by just sort of tacking a Google form into all of the body of all your alerts. Another trick that I learned once was you could put a link in it, like just an href link, like many alerting engines support Markdown, and say, click if this was helpful, click if it was bad. And then that goes to just a URL of a static image that's like, thanks. And then you use access logs afterward to determine how many people clicked on the link that was good versus bad, and that maybe includes the URL having the ID of the alert in it, something like that. All cheap ways of collecting feedback. Pull requests, which is something that Terraform Cloud empowers, well, Terraform in general, but Terraform Cloud makes especially easy. We can use the pull requests to have conversations. Maybe I'm new to the team and I don't really know what I'm supposed to change this alert to. I'm not comfortable changing an alert by going into the UI. It feels like I'm sneaking around. So instead, by using the pull request, not only do I get permission from the team becomes aware that I've made the change. And eventually you can get into something called detection theory, which is how many false positives, how many false negatives, and an analysis of the performance of that alert. I feel like I've gone a little too slow, so I'm gonna speed up a little bit. In addition to just building good alerts, good dashboards, all that kind of stuff, and handling modules, I'm gonna go a little further. This isn't specifically about Terraform, but it's the reason Terraform exists, is that someone realized, hey, we've got all these great APIs, and when you know these APIs, you can build some really cool tools on top of the vendors or the open source tools or whatever it is that you happen to use. Hopefully it's Splunk, but that's fine. Everybody uses different stuff. So one of the things that you can do, and this is something that Terraform and Sentinel, which Michelle mentioned earlier. So Sentinel is a tool that allows you to create policies for Terraform. So you can say, hey, we need every single dashboard that you build to include, I don't know, a link to a runbook. Or maybe there are certain tags that we assume need to be on all of these things. Sentinel can enforce that for you. And over time, you can even grow and learn from that. So, people make new detectors and make new alerts. Maybe they forget that you really shouldn't have an alert that only sends messages to Slack or to email. That's the big one. Everybody loves to send alerts to email, and then you just sort of like filter them out into a spam box and you never look at them again. So this is the type of stuff that you can help enforce with something like Sentinel, which again, Terraform Cloud makes super easy. We can also reduce a lot of friction because those pull requests mean people don't have to go and sneak around to change stuff, or they don't have to have, or if they are going to have arguments, at least they can have them on GitHub. So we can use pull requests to keep everyone in the loop, and then we can apply all this stuff automatically. So Terraform Cloud, HashiCorp was nice enough to give me access to Terraform Cloud when I was working on this talk, and it made applying things so easy. All I had to do was merge to master. It was applying it directly to production. I could see the run. I could understand the output and everything. And then that also handled governance so that I could say, hey, was I doing the right thing when I set up this alert or set up this dashboard? It's even got cost analysis so that we can understand maybe, that doesn't affect SignalFX the same way, but maybe for AWS or whatnot. And then lastly, even module management. So if you're putting this stuff in a module, all people have to do is import that module, specify their service name, and they get all this stuff for free. So way less friction for them. Some examples of some stuff that you can build if you know the APIs. So we've already talked about Terraform, how cool that is, and that came from just, hey, we could do this if we use the API. I built a little tool during a hackathon that analyzes alerts, similar to what I described with the case method earlier, and just says like, hey, how can this alert be improved? It gives you information like, this alert hasn't ever fired, or it's only a week old, so I'm not really sure yet. It can give you information that, hey, this has got too many time series in it, or your math is broken. It does all this analysis for you. You could build something like this yourself with just about any provider, but the API allows you to do that. And the reason that I mention this is that the more you know about the API, the more powerful stuff you can do. So it's really, really worth investing in the tools that you as an organization have chosen to build, whether it's learning how Terraform works so that you understand it better, how something like SignalFX works so that you can write a tool like this, whatever. The more investments you put in, the more likely that you're going to know how to get more out of that tool. Another example is I have a quick Python script that I share with people sometimes that just goes over all the detectors and dashboards and uses a quick regex to just analyze all the queries to say, here's all the metrics you're using. And you can easily go and get from SignalFX or maybe from whomever a list of all your metrics. And then whatever the intersection or the difference is tells you a lot. Like, here are all the metrics I use. Here are the ones I don't. Why am I not using these metrics? They're costing me money. Should I continue to emit them, or could I clean them up? And this is a very easy thing to do via API. And again, the type of thing that when you, when Hashi was originally writing Terraform, it's like, hey, we can do cool stuff with this, and you can too. One last example, heavy hitters, like go find the tags that contribute the most to the time series that you create. Another easy thing to do with the API. And then you can decide whether or not those are really useful in practice. So right here at the end, now I think I'm out of time. If you want to get started with this kind of stuff, this is echoing a lot of what Michelle said earlier. There's great documentation for learning how to spin up stuff with Terraform. You can go and get that at learn.hashicorp.com/Terraform. SignalFX, of course, you can go to signalfx.com/free trial. And then lastly, the Terraform provider is listed under the official providers on the Terraform website. And so you can go check out all the documentation there, or you can also find it on GitHub. It's called SignalFX Terraform Provider. And if you have any questions or thoughts on how it could be improved, I would love to see GitHub issues for it. But a summary of all the things that I've said here to wrap it up, the whole point here is to help folks with good design and practices when it comes to how you're using your observability tools and how great Terraform can be at helping you do that. The goal is, again, to reuse and modularize. Michelle, you joked about having trouble tripping over the word observability earlier. Mine's modularize, apparently. We can sort of use this wherever possible to sort of raise the water level for everybody. We create lots of opportunities then for feedback by sort of plugging in that feedback loop into any of these products. And then lastly, we can use these governance tools to sort of shape how the tool is functioning going forward. Like, we can say, we had a bunch of alerts, but we found out that this particular type of alert wasn't really helpful. So let's put that into Sentinel. Let's make sure that that stops us from making those types of alerts in the future. And then we're overall going to have maybe less noisy alerts and more actionable alerts. And another plug for signalfx.com/free trial at the end. Product marketing should be happy with me. Please enjoy doing this stuff. And now we can get around, I think, to questions and stuff. I'll just leave this up for a little while, though.
Thank you, Corey and Michelle. At this time, we're going to open up for questions. I think, Michelle, you already have a few questions that you'd like to respond to.
Yes. So one of the questions is Terraform Cloud FedRAMP? If not, is there a roadmap to achieve this? Currently, we don't have that certification. At the moment, if you have very advanced security requirements, most of those customers just choose Terraform Enterprise. But I will pass this request onto our product team. So that's what I got. Next question. Oh, I'll just go down the line. When can we expect a release candidate for Terraform 0.13? Currently, it is in beta, and I'm going to go ahead and plug in. I could just give you the link to the release candidate now, but plugging in a blog post, which gives you all the information you need to know, as well as where to find it and instructions. In terms of the GA date, my product team would not be happy if I release that, but just to give you some perspective, the beta started mid-June, so it's fairly mature at this point. We have had some issues raised in GitHub, so if you have issues, you can just file a GitHub issue on Terraform 0.13. And then we do recommend, if you have feedback, we have a Terraform community that you can plug that into. But yeah, I can't specify a date, but coming soon. for GA. I think, was that it for me? Oh, somebody also asked if Terraform Cloud worked with GitLab. It does. It works with GitHub, GitLab, and Bitbucket. Those are the version control systems you can use.
And I think there are a few questions for Corey. Can you repeat about read and use? Is one of the questions that was posed.
Yeah, sure.
Yeah.
So I'll give credit to the people that created them as well. So read is requests, errors, and durations, and it was created by a fellow named Tom Wilkie, who at the time I think worked for Google, now works for Grafana. But the idea is like, how much work am I getting? So that's what the request is. Let's count that up. How many of those requests turn out to be errors and suboptimal outcomes? And then D is duration. So how long did they take? So that's read. Use was created by a fellow named Brendan Gregg, who works for Netflix, and that stands for utilization, saturation, and errors. It's a little harder to measure because not every system can easily say, I was working for 30 seconds out of the last 60. It's a little more advanced. But the idea is like, how busy is the thing? Like, does it have extra time? Is it like sort of twiddling its thumbs and reading Reddit? And then saturation is how deep the queue is. So how many things are waiting to be handled. So you often see this like queued up as connection pools or something like that. And then lastly, E is error again. So it's basically the same thing. You commonly see use applied to things that have finite resources like IO, memory controllers, that kind of thing, because they, like we like to use infinite queues in a lot of our things. So it's sometimes hard to measure that in normal systems, but that's read and use. I'll just keep going through these questions that were already here that were related to me, just like Michelle did. Are there any plans for an official provider for Splunk dashboard, save searches, alerts, etc.? Watch this space. I'm not sure how much more I can say, but I know that there's work internally for both Splunk and VictorOps Terraform providers. Some of the code even already exists in some places, but releasing one of these things takes a little bit of effort. Like HashiCorp expects a certain level of quality, which is awesome. And we also expect to make sure it uses all the right APIs and that everything's good. So when we put it out there for you, it does the thing. But I'm engaged with those teams because I helped get, or I put the SignalFX provider out in the world as an official provider. So I'm going to help make sure that we get official providers for Splunk and for VictorOps as well. So yeah. If I have SignalFX for monitoring, do I still need Splunk? Of course you do. You need all the things. I'm just kidding. I'm not picky about this. Like, I'm not gatekeepy about how observability works. You can sort of use whatever tools work best for you. They each have sort of different things that they're good at. It's like any tool, right? If you want to, you can build an entire house with a screwdriver. Do you really want to do that? I don't know. Depends on your plans. But no, you don't have to have it. But it is certainly really, really good for things like monitoring real-time metrics and APMs and great mental models of tracing and how your systems work and all that sort of stuff. That was that question. How do postmortem / root cause analysis fit into observability with regards to the feedback loop? First off, there's no such thing as a single root cause. I have to be picky about that because there are lots of causes that cause incidents to happen. But yeah, so the point of it is that whenever you're going through and you're analyzing these incidents and trying to learn from them, and in some cases you will in the short term say, hey, we really do need to monitor for some innocuous thing like file handles, because it caused an incident last week. And until we fix the bug with file handles, let's monitor for that. But really long-term observability well, mostly observability is about providing information to the operator about what's going on. And I think the goal I would give you, Ryan, in that question, like how do postmortems and stuff fit in, is when you do your postmortems and when you're analyzing the incident, you're going to learn. Like, well, during that moment, the operator wasn't sure what to do because of these things. And in that case, Karen, could you mute your keyboard's clacky? Thank you. So in that case, we see, well, we needed to give the information to the operator slightly differently, or they didn't know this because of these reasons. And in many cases, observability will help you provide better in situ information to the operator. That doesn't mean necessarily staring at charts or being alerted. Sometimes maybe your build tool or your deploy tool needs to also pay attention to some other things. Like maybe the deploy tool shouldn't try to do a deploy if the hard drive is full on the box that it's deploying to. And maybe that should be a preemptive check, or not a preemptive check, a precursor check that we do before we deploy anything. And so in many cases, observability is going to help you answer questions about why the operator wasn't sure what to do, or why it took time for the operator to find the easiest way to solve the problem. You're very, I mean, you will often have incidents where you're like, okay, we got to add this chart or we got to add this alert, but I want to try to guide people into the learning mode instead of just the fixing mode. The idea here is to sort of learn from the experience and find out what we could do as an organization that improves the process, or what we can do to improve the process for the operator. That was probably a very vague answer, and I apologize if it doesn't quite hit the mark. Feel free to answer more questions. I think we got 3 more minutes, but hopefully that helps a little bit.
Corey, there were 2 other questions that are still open. Corey?
Nope, I got both those. That was unless I can't see them right because I don't know how to work it. So I got I'll hit done, answer, done. Sorry, I didn't know I was supposed to mark them off. You're right. Now they're done.
No worries, no worries. Okay. I think we have no more questions coming in. Oh, there is one question. How will the process, I think for Michelle, how will the process of using providers change in Terraform 0.13?
Yes. In previous versions of Terraform, if you were using a community provider, it was a very manually intensive process. You had to manually install it locally on your machine. And if you go across an entire organization, that's kind of a pain. With 0.13, if you have a community provider that works with 0.13, it will 0.13 will automatically recognize the namespace, and it automatically installs the same way that an official provider does as well. So way easier to set up, and it should give you a lot more flexibility with a lot less work.
And see, another question for Corey. Does SignalFX support distributed tracing or custom metrics? How can I use the provider to create application-specific dashboards? And I think that would be our last question.
Yes to all those things. It does support all of those things. There's 1 or 2 bits of the Terraform provider that sometimes aren't represented, or the product can do a few things that Terraform provider can't. That's usually because nobody has asked yet, or they are new features. Please let me know if you run into a situation about that. But it supports all the distributed tracing stuff, alerting on those distributed traces. And then, sorry, I was having to remember all the questions. And then custom metrics, absolutely. That's bread and butter to many of the things that we do. And then lastly, application-specific dashboards. That's a lot of what we talked about today. Like you can basically, we have a bunch of built-in content that'll give you value day 1. But of course, every organization is building something custom internally. And so you can use these, you can either build them by hand using the UI. You don't have to use the Terraform provider, but you can use the Terraform provider if you want to sort of bring it out and get a lot of the benefits that we talked about today. But yes, it supports every one of those things.
Thanks, Corey. We are coming to the top of the hour. So thank you again, Corey, Michelle, and thank you to the audience. I hope everyone enjoyed today's webinar and has a better understanding of observability as code with Terraform and Splunk. And finally, as mentioned at the beginning, this webinar was recorded and we will make the recording available after processing. I will send an email to everyone who registered with a recording link. Have a great day. Goodbye, everyone.